The field of remote sensing and GIS has become an important part of day-to-day technology. In the last 2 decades, innovative technologies have been greatly applied to experimental and operational activities. These technologies have their historical antecedents. For instance, remote sensing and GIS have been developed from earlier technologies such as surveying, photogrammetry, mathematics, and statistics. In today's world, modern technologies is an essential starting point, and they are the necessary tools to explore the characteristics of spatial phenomena. In this session, we will discuss about the definitions of remote sensing, the history of remote sensing, comparison of remote sensing to traditional field observations, advantages of remote sensing, disadvantages of remote sensing. Remote sensing system. The remote sensing is a science and art of obtaining information about an object, area, or the phenomenon through an analysis of the data acquired by a device which is not in contact with the object, area, or phenomenon under investigation. In the present context, the definition of remote sensing is restricted to meaning of process of acquiring information about any object without physical contact in it in any way, regardless of whether to the observer immediately adjacent to the object or millions of miles away. In simple terms, remote sensing data basically consists soft wavelength intensity information acquired by collecting the electromagnetic radiation leaving the object at specific wavelength and measuring its intensity. Remote sensing is a use of satellites, planes, and other aerial technologies using advanced sensor technologies able to detect energy reflected from Earth's surface. Is it possible to collect data in inaccessible or dangerous areas where it would be hazardous to bring in a team and equipment to collect the data? The sensors are highly above the Earth. They are very useful for gathering data in a very wide area. Remote sensing system comprises of measuring and recording of electromagnetic energy reflected from or emitted by a plant surface and atmosphere from the vantage point above the surface and relating of such measurements to the nature and distribution of surface materials and atmospheric conditions. The reflected energy by the Earth's surface captured by the sensors mounted on the aircraft or satellite platforms. Literally, remote sensing means obtaining information about an object, area, or phenomenon without coming in direct contact with it. If we go by this meaning of remote sensing, then a number of things would be coming under remote sensing. For example, seismographs, bathymeter, etc. Without coming in direct contact with the focus of earthquake, seismograph can measure the intensity of the earthquake. Likewise, without coming in contact with the ocean floor, fathometer can measure its depth. However, modern remote sensing means acquiring information about the Earth's land and water surface by using reflected or emitted electromagnetic energy. Main reason why the remote sensing has become so important in recent years because of 2 reasons. 1. In present context, everyone from students, scientists, researchers, and even a common people are trying to understand the environment and how sustainability can be achieved. It means how the geographical space of a study area, how are they influencing the surroundings and within the environment, as every interaction performed by humans have influenced or dictated by some factors of geography. Second, the advancement of technology and the lowering cost of hardware and software along with the need to interpret large geographical area in limited time has led to development of technologies in remote sensing. Definitions of remote sensing. From the following definitions, we can have a better understanding about remote sensing. According to White, remote sensing includes all methods of obtaining pictures or other forms of electromagnetic records of Earth's surface from a distance and the treatment and processing of the picture data. Remote sensing then in the widest sense is concerned with detecting and recording electromagnetic radiation from the target areas in the field of view of the sensor instrument. This radiation may have originated directly from separate components of the target area. It may be solar energy reflected from them, or it may be reflections of energy transmitted to the target area from the sensor itself. According to American Society of Photogrammetry, remote sensing imagery is acquired with a sensor other than, that is, or in additional to a conventional camera through which a scene is recorded, such as electric scanning, using radiations outside the normal visual range of the film and the camera microwave, radar, thermal, infrared, ultraviolet, as well as multispectral special techniques are applied to process and interpret remote sensing imagery for the process of producing conventional maps, thematic maps, resource surveys, etc. In the field of agriculture, archaeology, forestry, geography, geology, and others. According to the United Nations, remote sensing means sensing of Earth's surface from the space by making use of the properties of electromagnetic wave emitted, reflected, or diffracted by the sensed objects for the purpose of improving natural resource management, land use, and the protection of the environment. According to James B. Campbell, remote sensing is the practice of deriving information about the Earth's land and water surface using images acquired from an overhead perspective using electromagnetic radiation in one or more regions of the electromagnetic spectrum reflected or emitted from the Earth's surface. History of remote sensing. The knowledge about the history of remote sensing is necessary for better understanding of the subject and its scope, and also for the future development, particularly for the welfare of the human society. The development of remote sensing over time can be broadly divided into 6 phases. Phase 1 up to 1920, that is the initial phase. Man always inquisitive about the things across a forest or a mountain which he cannot see directly. So, since the time immemorial, man has always tried to reach greater heights such as the tree tops, mountains, etc. to observe the phenomena of his interest on the earth's surface, that is, to decide a habitat places or farming and other day-to-day activities. This inquisitiveness to get the bird's eye view prompted man to take photographs of the earth from the elevated platforms. So, the initial photographs of the earth were captured from the elevated platforms on the surface of the earth. However, the actual beginning of remote sensing can be traced back in 1859 when free balloons were used for photography by the French Gaspard Felix, also known as Nadar, to photograph a village of Tetel-Becquetre near Paris. With this picture, era of Earth observation and remote sensing has started. In 1860, a part of Boston and Massachusetts were photographs from a captive balloon at 1200 feet height in USA. In 1909, the first aerial photographs was taken from an aeroplane piloted by Wilbur Wright over Centoselli, Italy. World War I provided a boost in the use of aerial photography. During that time, aerial photographs were used for 2 purposes. One for spying and the other one is for mapping. Phase 2 from 1920 to 1945, that is, development of platforms and sensors. Improvement in aeroplanes, cameras, films, etc. resulted in development of aerial photography during this period. The proper planning of the flight for photographic purpose was also started. Topographical mapping was the main thrust of the aerial photography. However, a number of scientists like geologists, botanists, soil scientists, geographers began interpreting the photographs to get information of their interest, especially for the development of natural resources. During this period, photographic coverage were increased both on the large and medium scale. World War II gave a real boost to the photo interpretation technique, which was widely used for military intelligence purposes. The mapping of strategic location, military targets, and assessment of damages could be done accurately. Phase 3, 1945 to 1950, that is, development of teaching and training. After World War II, much emphasis on teaching and training of this technique was given due to previous experiences of its wide use in different spheres. Many courses on remote sensing were started in reputed universities of United States and Western Europe countries. A commission on the utilization of aerial photographs was set up by International Geographical Union (IGU) in 1949. The members of the commission emphasized the need of the knowledge of those parts of the world which were not earlier photographed, and also attention was given to cover more area by aerial photographs and techniques essential for interpretation. Phase 4, 1950 to 1960, development of instruments for interpretation. In this phase, the techniques of photo interpretation became much more an applied technique. A number of instruments was developed and introduced for interpretation during this period, which may be termed as a landmark in the progress of these techniques. It opened a new horizon for accurate and fast analysis and also for monitoring the changes. Hence, a considerable advanced interpretation was made in many disciplines such as geography, geology, geophysics, agriculture, and archaeology. Phase 5, 1960 to 1985, significant phase. This phase is very significant in the history of remote sensing as artificial satellites were launched in the space for acquiring information of the Earth's surface. Though two American satellites, that is Explorer 1 and Explorer 2, were launched in 1958 and 1959 respectively under Explorer and Discover program. They were not important from remote sensing point of view. On 1st April 1960, one satellite of 8 members of TRIOS, Television and Infrared Observation Satellite family, was launched as a research and development project. As the TRIOS name suggested, the satellite carried two types of sensing devices. First, television, camera, etc., which took pictures of the visible spectrum, and secondly, the infrared detectors, which measured the non-visible part of the spectrum and provided information of local and regional temperature of the Earth's surface. The supply of remote sensed data of the Earth's surface was greatly increased with the launch of ERTS-1 Earth Resource Technology satellites on 23rd July 1973. It was placed in a sun-synchronous polar orbit about the 600 miles above the Earth's surface. It makes 14 revolutions in a day around the Earth, and its sensors were covering a series of 160 kilometers wide strip. Then it was followed by ERTS-2 in 1975. With the launch of this satellite, the name of these satellites has been changed from the ERTS-1 and 2 to Landsat 1 and 2 respectively. 4 other satellites in these series were launched one after the another in this phase, with improved cameras and sensors. Beside this, many other satellites were launched in the space by European and Asian countries during this period. Phase 6, 1985 onwards, recent development phase. In this period, remote sensing technique has been improved in 2 ways. First, there have been development of sensors which can use infrared and microwave spectrum other than the visible spectrum to get information about the Earth's surface. Secondly, there have been very important advances with respect to the platforms in which sensors are mounted. Besides, satellites have been launched for specific purposes and with specific capability. The ground resolution is continuously increasing till today. Hence, interpretation and mapping is becoming very easy, accurate, and purposeful. The European radar satellite ERS-1 launched in 1991 opened the avenue for the systematic global observation in the microwave region. The French satellite SPOT is producing the imagery to provide three-dimensional view with stereoscope. The satellite IKONOS, launched on 24th September 1999, has 1 meter resolution in panchromatic and 4 meter resolution in multispectral cameras. USA, France and India have planned a series of satellites with improved capability so that the users are assured of continuity of data. Milestones in history of remote sensing. 1800. Discovery of infrared by Sir W. Herschel. 1839. Beginning of practice of photography. 1847. Infrared spectrum shown by J.B.L. Foucault. 1859. Photography from balloons. 1873. Theory of electromagnetic spectrum by J.C. Maxwell. 1909. Photography from airplanes. 1916. World War I aerial reconnaissance. 1935. Development of radar in Germany. 1940. World War II applications of non-visible part of electromagnetic spectrum. 1950. Military research and development. 1959. First space photograph of Earth, that is Explorer 6. 1960. First TRIOS meteorological satellite launched. 1970. Skylab remote sensing observations from space. 1972. Rapid advances in digital image processing. 1986. French commercial Earth observation satellite SPOT. 1986. Development hyperspectral sensors. 1990. Development of high-resolution Phase 1 systems. First commercial developments in remote sensing started in 1991 with the launch of radar satellites ERS-1, RadarSat by Canada, Ichnos, QuickBird, Aqua by NASA, etc. Comparison of remote sensing to traditional field observation. The human ability of observation places the subject and individual. Humans observe and process information in real-time period, and reciting the image recorded in the memory is also an indecent process and it's time-bound. We can list the following properties of remote sensing. Remote sensing instruments make it possible to observe the environment with electromagnetic radiation outside the visible part of electromagnetic spectrum. The invisible becomes the visible. Remote sensing produces measurable physical data so that we speak of objectives. Hence, it is possible to acquire quantitative as well as qualitative data about the Earth's surface. Remote sensing gives position-bound thematic information connected with the parameter, that is, what, where and how, for improvement and completion of existing maps. Remote sensing is flexible in that there is a variety of remote sensing observation techniques and a diversity of digital image processing algorithms for searching optimal route information about the Earth's surface. The synoptic element of remote sensing is unequaled, giving an overview of the region as a whole. The coherence and the limits of the component of the region can be distinguished and identified. In the past, this coherence could only be derived from theoretical consideration or conjunction from the other data. Remote sensing provides area-wise information, making the traditional way of the point-wise sampling of the Earth's surface more selective. Remote sensing allowed for an image recording of a large area in a very short time. This advances the internal correspondence of the thematic information that is aimed at. In addition, there is a high degree of actuality in comparison with the conventional methods of mapping. Remote sensing data disclose processes on the Earth's surface both with regard to instantaneous reproduction as well as change detection. Hence, remote sensing can be considered to be dynamical. Remote sensing satellite images may open up inaccessible regions, at least they give for the basis further in the knowledge about these regions. Remote sensing as a source of information may repeat, alter and improve the analysis of the images as soon as our prior knowledge is augmented or deepened. Images of the observed object can be stored and compared with more recent images at the later time. Advantages of remote sensing. Remote sensing has come a long way in recent years and is impressive surveying technique with many different advantages. Remote sensing technology allows coverage of very large area with any regional service on various aspects and also identification of various features of a large area. Remote sensing is a fast process sensors used to measure light deflection from the surface are mounted to an aircraft, drone or even a satellite. This positioning of the sensor allows to cover a large area in the short time period. By surveying from the air, the remote sensing sensors are also able to scan and create maps of inaccessible areas. Remote sensing allows repetitive coverage, which is helpful in collection of data on dynamic themes such as water, agricultural fields, environmental degradation, etc. Remote sensing data can be used in 4 different applications over a variety of scales and resolutions. For example, data might be collected by remote sensor to survey site for construction. However, same information could also be used to analyze and plan new roads, or data collected from the forest to monitor the risk of wildfires could also be used to monitor biodiversity. Remote sensing technology, LiDAR, cloud data until recently was hard to process, but now this data can be quickly and easily analyzed with the point cloud software. As data is analyzed in a laboratory using software, this limits the work needed window in the field. Small teams can carry out surveys and analysis post-scan. A single image captured through remote sensing can be analyzed and interpreted for the use in various applications and purposes. There is no limitation on the extent of information that can be gathered from a single remote sensed to image. There is no disturbance of people in the environment caused by the remote sensor, as it measures reflected light, either natural sunlight or a light pulse light is harmless to objects, vegetation and people. So remote sensing does not disrupt the scanning process. So it is perfect for surveying built up areas, or there is no need to close roads and cities so that the business can be as usual. Remote sensing allows for map revision at a small to medium scales, which makes it a bit cheaper and faster. Color composite can be obtained or produced from 3 separate bands images, which ensure the details of an area are far much more defined than only using a single band image or aerial photographs is being reproduced. It is easier to locate floods or forest fire that has spread over large region, which makes it easier to plan a rescue mission easily and fast. Remote sensing, if a relatively cheap and constructive method, reconstructs the base map in absence of the detailed land surveying methods. Disadvantages of remote sensing. Unfortunately, nothing is without limitation, and remote sensing does have some disadvantages. While the advantages outweigh the downsides, it is good to consider the cons of the remote sensing. Remote sensing is a fairly expensive method of analysis, especially when measuring or analyzing a small area. Remote sensing changing requires a special kind of training to analyze the images. It is therefore expensive in the long run to use remote sensing technologies, since extra training must be accorded to the users of the technology. Remote sensing is expensive to analyze repetitive photographs if there is a need to analyze different aspects of the photographic feature. It is humans who select what sensors need to be collect the data, specify the resolution of the data and the calibration of the sensor. It is easier to introduce human error in this kind of analysis. Powerful active remote sensing sensors such as radar that emit their own electromagnetic radiation can be intrusive and affect the phenomena being investigated. The instrument used in remote sensing may sometimes be uncalibrated, which means to uncalibrate remote sensing data. Sometimes different phenomena brings analysis may look the same during the measurement, which may lead to the classification error. Analyzing sometimes can be inferred by the other phenomena that are not being measured, and this should also be accounted for during analysis. Remote sensing technology is sometimes oversold to the point where it feels like it is a panacea that will provide all solution and information for producing physical, biological, and scientific research. The information provided by remote sensing data may not be completed, may be temporary. Sometimes, large-scale engineering maps cannot be prepared from satellite data, which makes remote sensing data incomplete. Summary: remote sensing is a process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance, that is, typically from a satellite or aircraft. Remote sensing is a type of geospatial technology that samples emitted and reflected electromagnetic radiation from the Earth's terrestrial atmosphere and aquatic ecosystem in order to detect and monitor the physical characteristics of an area without making a physical contact. Remote sensing, also called the Earth observations, refers to obtaining information about the objects or areas at the Earth's surface by using the electromagnetic radiation, that is, light, without being in direct contact with the object or area. So, remote sensing is a day-to-day business for people. Reading the newspaper, watching cars driving in front of you, looking at the lecture during the course are all remote sensing activities. The human eye observes the solar light reflected by the objects. In the brain, the inputs of the colors, the gray tones and intensity variation are stored. Next, the data is translated into the useful information. The human eyes, however, is limited to a small part of total electromagnetic spectrum, that is approximately 400 to 700 nanometers. In remote sensing, various kinds of tools and devices are used to make electromagnetic radiation outside the range from 400 to 700 nanometers visible to human eye, especially the near infrared, middle infrared, thermal infrared and microwaves. Increasingly, the remote sensing is used to acquire information about environment, rate processes, search ends, agricultural crop growth, common land coverage changes, deforestation, vegetation dynamics, water quality dynamics, urban growth, etc.